Hi, my name is Matt Usher. I'm a senior program manager at Microsoft, working on the Azure SQL Data Warehouse Service, Analytics Platform System Appliance, and Polybase in SQL Server. Today we're going to talk about the Azure SQL Data Warehouse Service. So when we look at the Azure ecosystem, there's a variety of products and services available to you. Specifically today we're going to talk about the data pillar of the Azure ecosystem, and specifically the Azure Data Warehouse Service. And this is down in the data component alongside products like SQLDB, the Redis Cache, and DocumentDB. So what is Azure SQL Data Warehouse? Azure SQL Data Warehouse is a relational data warehouse service fully managed by Microsoft, running as a managed cloud service. It introduces the first elastic cloud data warehouse with proven SQL Server capabilities. When we talk about the ability of a data warehouse to grow, SQL Data Warehouse starts from the smallest of data warehouses and grows to the largest size through contiguous storage. The SQL Data Warehouse service is built on three pillars, the first being this pillar of elastic scale and performance. SQL Data Warehouse introduces the concept of split storage and compute. The separation of storage and compute allows you to dynamically scale each one of those components independently of the other, allowing you to grow your storage or to grow your compute as your business needs. The second component of this is really this ability to resize the compute infrastructure on a moment's notice. Currently today, the Azure SQL Data Warehouse Service allows you to resize the compute component of the service from any size to any size, from smallest to largest or anything in between, in less than 60 seconds, allowing you to scale the system on a moment's notice to meet a business problem. And finally, the service is designed for this on-demand workload concept. Really, SQL Data Warehouse allows you to run fully on-demand 24/7, as truly any enterprise data warehouse service would, but also allows you to burst, giving you the capabilities of managing and monitoring scenarios that you've never been able to in the past. For example, with Azure SQL Data Warehouse, you're capable of running an ETL job that traditionally maybe have taken 3 or 4 hours because you're running it through a single node. Scale the service up, run that job in parallel, and run it in a lot less time, and then scale the system right back down when you're done in order to offer dashboards, KPI reportings at a scale that's cost effective. The second pillar is the integration with all of the other Azure services as a first-party Azure data warehouse. When we think about all of the different ways that a data warehouse is built, storage and compute is only one component. So we really truly think about all of the integrations with Azure SQL Data Warehouse. This includes things like first-party built-in integration with Azure Machine Learning for deep predictive analytics and other machine learning scenarios. Streaming insights or streaming analytics to allow stream insights of data coming out of IoT scenarios, data that's being emitted from the cloud or devices into the cloud, being able to see that in real time via stream analytics, and then to land that data in SQL Data Warehouse for further analysis, machine learning, predictive analytics. Finally, things like integrations with Power BI to be able to allow you to very quickly visualize that data without having to go through a long, complicated setup. Additionally, the Azure SQL Data Warehouse Service has a wide variety of partners and certified third-party packages that allow you to pull into the environment all of the products and services that you may use today. This includes things like reporting, monitoring, management, data movement tooling that allows you to take the infrastructure that you have today and use SQL Data Warehouse as a component of your overall data warehouse solution. Finally, SQL Data Warehouse introduces a technology called Polybase, which is the capability of running both structured data through the Azure SQL Data Warehouse, as well as semi and unstructured data in systems like Hadoop, specifically HD Insight, running in the Azure cloud or on-premises in your environment. Polybase enables you to query both that structured data and that unstructured data through a single T-SQL-based statement, producing the necessary MapReduce or Yarn jobs into the Hadoop environment, gathering and executing those jobs, pulling the data back into the SQL Data Warehouse service, and then manipulating and acting upon it just like you would any other relational table within the data warehouse service. The last pillar is truly market-leading price and performance. The Azure SQL Data Warehouse, built on this concept of split storage and compute, offers a very simple billing model. From a customer's perspective, this means that you really truly only pay for the services that you use. So if you happen to use very little compute, then you're going to pay for very little compute. If you happen to use a lot of storage, then you're going to pay for the commodity storage rates for storing that data. But it really truly is a consumption-based model, allowing you to scale up the system and have a predictable bill based on the usage that you've actually incurred, and not on some predefined SKU that you're having to decide, is this the right volume or value for me and my business? It also means that with this introduction of separation of storage and compute, we have the capability of doing some amazing things with the technology. One of the amazing aspects of SQL Data Warehouse is the ability to pause, which means we can remove the compute component and leave your data in place in very, very cheap commodity storage, allowing you to save cost whenever there's an environment where you're not using or fully utilizing the system. For example, nights and weekends. It's often the case in data warehouses that you have a traditional EDW model with a hub and spoke or data mart models where the users of that system aren't using it over the weekend or aren't using it in the middle of the night. So you're able to turn off the compute component, save the cost of having the compute running over the system, and then turn it right back on, very simply by either API or even better, through just a simple pause and resume button in the UI. Finally, when we think about that data being stored and the ability for you to be able to manage and support the system, it's truly a managed service running in the Azure cloud, giving you all the capabilities that you would expect from a managed service running from Microsoft. So let's now go take a look at the Azure SQL Data Warehouse service. The first thing I want to show you is the Azure Data Warehouse Blade. And what this is going to show you is the basic service running in the portal. And it has some key things that we can talk about. Some management capabilities up here in the command bar, which really define how you can interact with the service. For example, here's our pause button. This is a running instance, so I could go ahead and click the pause button, and we can actually turn the system off. It gives you the capabilities of doing this very quickly, simply through the portal UI. It's also scriptable, allowing you to be able to automate this through something like SSIS, where you can go pause the system when you're done with a load, for example, in the middle of the night. You know the service isn't going to be used for a few hours. One of the other key things to talk about is the scale. The scale blade gives you the ability to size the service based on what your compute needs are. Again, this is available through a scripting API, so through the REST APIs and PowerShell. But here in the portal, it's simply a matter of sliding the slider to the right, saving this, and you now have instant on compute, giving you more power for your computational needs. In the case of not needing all of that power, we can simply slide the slider to the left, giving you a smaller compute footprint, maybe for your daily reporting needs throughout the day, saving you costs and optimizing the system based on your business needs. So let's actually walk through a scenario. So here on the command line, we have a simple tool. It's used by the Event Hub and the Stream Analytics teams to demonstrate a telco scenario. This generator is going to emulate what a series of cell phone calls would look like into a telecommunications company, particularly a cell phone company. And what this is going to emulate is a bunch of phone calls being placed from one cell phone to another, and it's going to emit a couple pieces of key information. We're going to say that we're going to emit, about 1,000 calls an hour, and you can see here that we have a couple of additional parameters. The second parameter that you see is the percentage of fraudulent calls, and that'll become important in a minute as we talk about fraudulent scenarios. And the last is just a duration. So we're just going to have a set of data being generated. As you can see, the system is spooling up, and now this is a command line tool that's now starting to emit data to the cloud. So how do we go and capture that data, look at it real time, and then also report on it so we can start to do fraud investigation, for example? In this scenario, we know that in many places, SIM cards are duplicated, allowing multiple people to make phone calls on a single bill, causing the telecommunications company, a lot of charges to their system that they can't recoup from customers. So a real true fraudulent scenario. So what this tool is doing is it's now connected to the Azure Event Hub service running in the cloud. So let's go take a look at that. So if we look at the Azure Event Hub service, we can see that as I do a quick refresh, you can see that data is now starting to be emitted to the cloud. You can see a series of messages being delivered. This is truly a streaming service, allowing those events to flow into the system. But if we look at the configuration of the Event Hub, you can see that the message retention is traditionally for a very small period of time. In this case, the default being 1 day. And what that means is that while the data is being processed into the cloud, you can't really act on this data past that first day. You start to lose historical trends. You start to lose the concept of where events are happening in this stream of data. And so we're able to take a look at this and say, well, maybe we should be able to land that somewhere. Azure SQL Data Warehouse is a perfect candidate for that. In this case, we also want to do some real-time analysis of the data. So we're going to go ahead and take a look at Azure Stream Analytics. And Stream Analytics allows you to dip into that stream of data, in this case, cell phone calls coming from this command line application, and actually start to get some insight on that data. In this case, you can see some of the events coming in through the system. You can see the size of those events, the amount of data, that kind of thing. But really, the Stream Analytics system is based off of 3 concepts. The first is this concept of an input. And in this case, you can see that our input is our Event Hub. And this is where that stream of data is coming from our command line application. The second is a query. So similar to other systems, you can go ahead and take a look at the query we've built here. In this case, we're doing a simple select star from call stream, which is the source, in this case the event hub, and we're going to target into an output, in this case the call stream output. So let's go take a look at what that is. If we look at the outputs, you can see that we can add a bunch of different kinds. In this case, I'd happen to choose a database, in particular Azure SQL Data Warehouse database. And if we click into this, you can see that simply it's based on the 4 components of connecting to any database that you would expect: the server name, the database name, the username, the password, and a 5th parameter, which is the table to land the data in. So let's go take a look at that table. So here we have SQL Server Management Studio. And if we take a look at Management Studio, you'll see that I have a table called Call Stream All Events. And this is the target of the stream analytics stream coming from Event Hub, ultimately coming from those cell phone calls. And in this case, you can see it looks like a traditional stage table, where I've not typed any of the columns, and I've just added an environment for that data to land that I can then do further processing in, either in an ELT scenario where I'm going to do aggregations, or in a filtering model, which is what I'm going to show here for fraudulent call investigation. A couple of key things to call out. While this is all of the data that's being emitted, in this scenario, I don't really need all of it. A couple of the key things that we're going to need is the calling number, the calling IMSI data, which is the unique identifier of the phone, or the SIM. We're also going to look at the switch, which is the identifier of where the call was placed, which is the switch number. And finally, we're going to look at the call receive time, which is the time the call was actually placed. So I'm not going to create that table since I'm already streaming into it, but we can go ahead and we can take a quick look at the table itself. And as you can see, a quick count, I've got about 67,000 rows here. And if I run this in a second or two, you'll see that that row count will continue to increase as I'm emitting events to the cloud. Now let's go take a look at some of what that data is that landed in that table as a staging table. And if we pop into here, we can see that this is a very similar data set now in a structured model of that data being emitted from the console application. Again, emitting what is emulating cell phone calls. And you can see we have all of the different information. We have the switch number, so in this case, what area of the world is coming from, the calling number, the individual unique ID of the phone, the number that it called, and a bunch of information about that call. But we're not interested in that information. We want to figure out who's cheating the system. So if we go look and create a new type of data model, here in this case, we're going to go land a permanent table for us to do investigation and analysis on. We're going to do this in a new way. And this is the introduction of the create table as select statement, or a CTAS. And this is unique in the way that multi-parallel processing systems work. As a multi-parallel or MPP system, we would like to work in batches, allowing each one of those batches to be worked on by the individual compute nodes in the entire system. This allows for very high performance and very large scale, something that traditional SMP systems are bottlenecked on. And what this means really at the detail is that we want to work on things in those batches and not on a row-by-row operation. You can imagine that we have multiple compute nodes running under the covers, and each one of those compute nodes is able to process a set of data independently of the others, and then combine those results into a single output. In this case, I want to create a table from a select of another table. I want to call out a couple key features about the MPP system. The first is the create table statement itself. So if you're familiar with SQL Server, this is going to look very similar to the way that you would create tables in SQL Server. So you create table and define a name. You can add additional schema information if you'd like to place it there. In this case, I'm also going to introduce cluster and column store indexing. This is a columnar indexing representation of the data stored inside of this table. And you can find more details about that on SQL Server Online and MSDN. One of the unique things about SQL Data Warehouse is the ability to automatically distribute the data. So if you imagine we have this pool of data services or compute nodes running across all of these data, we want to be able to split that data or shard that data in a way that makes sense to the system. But as a user, you don't want to have to go manage those shards. So you don't want to have to worry about how am I distributing data on node A and node B and node C and try to really understand how to do that well. That's the beauty of the Azure SQL Data Warehouse system. You really have control of a logarithm that's used to distribute the data. You can either distribute the data in a round-robin fashion, which is just like it sounds. Row number 1 lands on node number 1. Row number 2 lands on node number 2. Row number 3 lands on node number 3. And if we only had 3 nodes, row number 4 would land on node number 1. And it continues to round-robin as it just loads data. In this case, I'm going to use a hash-based distributed table. And you can see this here with the syntax, distribution equals hash, and then the column I want to hash on. In this case, phone ID. And this is done for performance reasons. The reason you would do this is you create hashes of a similar data set that allows the data to reside in a single location or in locations similar enough that joins and optimizations for data retrieval and querying are optimized. So in this case, I know the data I'm working with. I know the queries that I'm going to run later in this demo. And so I'm optimizing performance based on my understanding of the data model I'm working with. I also wanted to call out that since this is just SQL Server, you have the capability of doing all of the things in SQL Server that you would expect. So in this case, data partitioning. In addition to data distributing, you can then partition the data within each one of those distributions to allow for further performance optimizations. In this case, you can see I've got just a simple data optimization for my partitions. Since we're only working with a single day of data, I'm not going to introduce that here. But I just want to introduce the concept that this is SQL Server, and you have the capability of further optimizing your queries by using partitions. You also have the capability of creating stage tables that allow you to simply load the stage table and partition switch over, so you don't have to go through the CTAS operation each and every time. If we then look down at the select statement that's generating this, and I'll highlight it here for just a moment, you can see that I'm simply returning the first 10,000 rows. I'm going to cast 2 of the columns because I care about those, specifically the phone ID. Now that's my hash-based ID column. And then the date time, because I want to be able to filter on date in a few minutes. You can also see that I'm filtering out, again, standard SQL Server syntax, the data where the data coming through the system is invalid. In this case, a date that's invalid. January 1st of year 1. Essentially, we know that that's an invalid date and there's something wrong with the data. In this case, I'm not going to look at it now. I'm just going to filter out. So if I go ahead and run this statement, what will happen is the system will now go execute that query, generate the table, and begin to flood it in a parallel fashion. And as you can see, we delivered 10,000 rows into that table very quickly. And again, this can be done at hundreds of millions, billions, and trillions of rows. Now what we want to do is we want to go take a quick look at that fraud table. We just want to make sure that my data got there. And if we go take a look, what we can see is there's the 4 columns that I created. I have my phone ID, my number called, my switch location, and my call receive time. And so really, truly, now I have some data that I can work with. The last thing we want to do is now we want to create a view. And again, this is the same syntax that you would expect to see from SQL Server. And I'm just filtering here so I can show you some of the highlights of syntax capabilities. So in this case, I'm using a top 100. Again, I'm just doing this here for demo reasons. But you can see that you can create all of the syntax that you expect. You can alias columns, you can join, you can filter. And in this case, you'll notice that I'm self-joining. And the reason I'm self-joining is I'm back to that fraudulent scenario. We're trying to figure out where is a customer had either their phone duplicated on purpose or fraudulently, where multiple calls are being placed from the same SIM card in different locations, all at the same time. So how I'm going to do that is I'm going to go look at all of the calls that were placed from the same SIM card, so joining on my phone ID, where the differential of the call was between 1 and 5 seconds, and the locations do not match. And since the locations in this case are country-based, it's pretty obvious that somebody's not going to be making a call from, say, the United States, and then 5 seconds later making one from somewhere halfway around the world. So we can probably identify that as a fraudulent scenario. So I'm going to go ahead and create the view. And again, it's the same syntax that you would expect to see in SQL Server, and I'm just going to go check my view just to make sure that it's working. And you can see, as you'd expect, I get a set of data now out of that original pool of data that's showing me, hey, here's some phone IDs that are fraudulent for some reason. So now let's go dive into that. If we want to pivot up back to the SQL Data Warehouse blade, one of the things that I didn't mention earlier was this Open in Power BI button. And what it does is it gives you the capability to go ahead and click that. It'll connect over to the Power BI system, and it will begin the process of creating a data set. So I'm going to go ahead and connect to my Azure SQL Data Warehouse. And you can see that Power BI has added the server, database, and username for me. And I simply just have to add my password. Oops. Click the Connect button. And Power BI will create a connection over to my Azure SQL Data Warehouse instance. At this point, Power BI is now inspecting that for tables and views that it can then use for visualizations within Power BI. So let's go ahead and create a dashboard here. So now you see on the right-hand side all of the fields that represent the tables and views from that Azure SQL Data Warehouse database. In this case, here's our view, fraud by switch. So we're going to go ahead and create a visualization. That's the switch location, and then the count of fraudulent calls from that switch. And right now, Power BI is just building a simple table. We can go ahead and convert that into a bar chart so it's a little easier to read. Now that we have this, let's go ahead and save the report. We'll call this the fraud report. Now that I've saved it, we can go ahead and open it. And Power BI at this point has now gone out, executed a query against the Azure SQL Data Warehouse using the power of SQL DW in order to scale that query out to hundreds, thousands, millions, billions, and trillions of rows, and done that very performantly, giving you the ability to go look at data that's in a very large data warehouse, and that could also grow with you as you grow up in your business. If we go ahead and refresh this, you'll see that we're going to go out and run those queries again. And it'll take just a few seconds for the system in Power BI to go ahead and go execute those queries, and again refresh this. And since the data is being refreshed in a different order, you can see that the chart changed. To summarize, Azure SQL Data Warehouse is a cloud service built on 3 pillars. The first is that it's fully elastic. With this dynamic nature offered by the separation of storage and compute, it truly offers a service that can model itself around your business, whether that's a very compute-intensive, a very storage-intensive, or a balanced-natured business. It really gives you the ability to power the service from one end of the spectrum to the other on your requirements, whether that's a change in the morning, a change in the afternoon, a change at the end of the week, a change at the end of the month, or let the system grow with you as your data warehouse grows over time. The second is that it's cloud-powered, allowing you to integrate with all of the other cloud services from streaming, from data loading, from managing and monitoring, all the way to visualizations, just simply with the click of a few buttons. Finally, it's a cost-effective service. With the separation of storage and compute and a very consistent consumption-based billing model, it allows you to predictably understand what your costs are going to be and to optimize the system around not only your cost, but your business need. To learn more about Azure SQL Data Warehouse, visit http://akams/SQLDW to get started today. Thank you very much.